This is Jenny Kunkel, and in this video we are going to take a look at one of the NoSQL databases, and that is MongoDB. This semester we've been focusing on relational databases, but there is another type of database that is popular and used in applications today, especially for those on the internet that require a lot of scalability, and those are the NoSQL databases. And NoSQL means not only SQL, not NoSQL. And in this case, when we think about the different types of NoSQL databases, there are 4 different main category types, and those are going to be the document-based databases, the key value stores, the column-oriented databases, and the graph-based databases. Now, the MongoDB is a document-based database, and the one that I'm using here is MongoDB Atlas, and this is something that is available on the web. You can go out and create a free version to play with, and that is what I have essentially set up. Now, I've used MongoDB with Sitecore. Sitecore was essentially a content management system that was implemented and used MongoDB, so we did lots of querying in the database with our documents, and it looks a little bit different from how we structure our relational databases. For a relational database, we separate everything into different tables, and then we join our tables together to get information back. With a document database, essentially you're going to be storing everything that's related to one document in the database together using JSON. And if we would think about it, if we were doing something for a sales order, we would be storing not only the sales order, all of its detail lines, the customer information, and all of that kind of information all in one document in the database. And we're going to go ahead and take a look at one of the schemas that I've loaded, and it's going to be essentially around movies. And we're going to go ahead and do a little bit of querying so you can see what they look like, how we can filter and sort. We're not going to go ahead and insert anything, but just to give you an idea of what the difference between the relational and a document-based one of the NoSQL databases looks like. Now, essentially what you need to do is sign up for an Atlas account. MongoDB is going to be in the cloud. You're going to have to set up your network IP address, and from time to time it may change. So if you can no longer connect, you're going to have to go back and add another IP address. That's the loveliness of cloud computing. Now we can switch over to Visual Studio Code. That's what I'm using to actually query the database. And one of the things that we can actually do is if we switch to our extensions, there is an extension that we can install, and that is MongoDB for VS Code. That's something that you can install. If you install it, notice that it has this leaf, and it will install something here where once it's installed, you can just click on the leaf and it's going to take you into your MongoDB connections. Then you can go ahead and expand it to connect, and as long as you have the IP address set up, it's going to connect and you'll be able to get into your MongoDB database. Now I have a couple different MongoDB databases. I have this Playground database that I installed when I went through the Atlas installation. It basically just put it there for me. I'm going to be using this movies, and we'll be querying against this movie. Now notice here we have documents, and I can actually double click on the document and take a look at what's in here. Essentially, it's going to be a very complex type of document. We can see that we have plots, we can have arrays, so genres, runtime, cast, poster, title, full plot, release date, directors, ratings, last updated. Then we can get into countries and then the movie ratings, and in this case, we can see the tomatoes, the viewers, and ratings, etc. So we have a more complex type of JSON document that's being stored in this database than what we were previously looking at when we were looking at JSON and selecting it from our SQL Server database. Now, if I decide that I want to go ahead and try to create some type of a query against this, I'm going to go ahead and on my database, which is the sample_mflix, I can go ahead and create a playground. And once I have that playground, then I can go ahead and query from this particular node once I get some statements in there. Maybe to start out, the first thing I want to do is query to see how many movies I actually have stored in this database. I can do that by doing a db.movies.aggregate, because we're doing that count. That's an aggregate function. Then I'm putting in an array, and then I have parameters. And in this case, I'm just doing a count. And I'm going to name the parameter total movies. Once I have my query set up, I can go ahead and there is an arrow over here and I can run it. It's going to give me a dialog that says, do you really want to run it? Kind of thing. And then I can see that I have 21,349 movies in this movies database. The next thing I want to do is maybe I want to find all of the movies where there is a cast member named George Barnes. I can go ahead and I'm just going to comment this out because I don't want it to bring back information for this now. This is going to be db.movies.find, and this is where I want to put within my curly braces what is the key. So the key is going to be cast. And then what's the value going to be that I'm searching for? And that's going to be George Barnes. Once I have that, I can go ahead and run my query. And it's going to find the documents that have George Barnes in it. So we can see George Barnes right there. And it looks like there's only one document that's being returned. So there is one movie. But what happens if we are really interested? We see that we have genres in here. Maybe we want to get a list of all the genres that are available within this database. How do we do that? Because that's with an array. Seems kind of funky. How can we get that back? So I'm going to comment this out. And then I can go ahead and do a db.movies.distinct. Then I'm going to get the genres. Then go ahead and sort those in order. Then if I run this query, it's giving me all of the genres that are in the database in order. Now, if I decide that I'm interested in retrieving any of the movies that have the genre of action or the genre of Western, and that's it, I don't want them all, I can go ahead and do a query here using an OR, and this is going to be dbmovies.find. Then I'm going to use the OR condition, and the OR condition, then I have to provide an array, and within the array, each of the conditions is actually going to be within curly braces. So this is going to be the first one where I have genres that are equal to action. So that's the first one. And then I'm going to put a comma. And then after the comma, put in another curly brace with genres. And this is going to be for Western. So then I can go ahead and run this. And we're getting our combination either having Western or action. We have an action right here. So we're getting one or the other. It doesn't have to be both at this point because we're doing that OR condition. But what about an AND condition? So I'm going to go ahead and comment this up, but actually copy it. And then we're going to fix it up a little bit. So in this case, maybe we want to find and use an AND condition. And we want to get either the action or adventure. So they have to be both. So if a movie has both of those specified in that array, then we should see those being returned. So if we go ahead and run this, we have a couple documents, it seems like, that are being returned that have at least those two. They could have more, Like in this case, they have action, adventure, and sci-fi, but they must have action, they must have adventure in the genres. So that's another thing that we can do. Now, if we decide that, okay, well, we really want to do this, we want to do this in condition, but that's a lot of data. We don't really want to return so much data. We really just want to return the plot, the title, and the genre. We can do that. And in this case, where we have our array, what we want to do is essentially put a comma after this, and then before, so this is going to essentially be related to this up here. Then after this, we're going to go ahead and put in another curly brace, and this is going to essentially be a list of fields that we can specify. And if we specify one, then it's going to include it. If we don't include anything, then it will not include it in there. But if we also put in something with a 0, then it's going to not include it. So in this case, we have the title that we want to include. So we're going to say 1. We have the plot that we want to include, and we'll say 1. And then, oops, put this inside, the genres that we want to include. So we'll make this one as well. So at this point then, if we run it, the amount of data that's being returned is a lot less, but notice that it's returning this ID for that document by default. If we really don't want to see that ID, we can exclude it, and that would be something that we would have to specifically include with an underscore ID, because by default it adds it. So if we did that and reran it, then it's showing us the documents that do not have that ID included, just the title, the genres, and the plot. But what happens if we want to sort this by the title? And to sort this, where we sorted the genres before, we only had one field, so it just assumed that we were sorting it by that. We can put in our sort condition, and when we do this, we have to put it within curly braces, give it what the field is, and this is going to be title. And then we have to determine whether we want to sort it in ascending order, sort it in descending order. So in ascending order, we would use a 1. If we wanted it in descending order, we would use a -1. So in our case, we want 1. If we had more that we wanted to sort it by, then we would go ahead and put a comma, and then go ahead and add our additional sort conditions within curly braces as well. So in this case, I can run it, and we should see that now they are in order. We have them in number order first before it starts with the actual titles. The last thing that we want to look at is we want to do a query where we're actually going through a couple layers of the JSON objects to take a look at what that looks like. So if we look at our documents, let's just pull one up again. And we looked at the tomatoes before. So the tomatoes viewer rating, we want to find the tomatoes viewers rating that are greater than or equal to 3.5. And we'll have to understand this hierarchy here in order to write the query. We're going to go ahead and comment this out again. And this is going to start with db.movies.find. And then what we want to put in here is our tomatoes. And of course, we need to put this in single or double quotes. And this is going to be viewer.rating. And we want this where it's greater than or equal to the value 3.5. So if we go ahead and run this, it's returned to us all of those movies that have a rating of 3.5 or greater. You can see 3.7, 3.6, 7.3, 3.7. So we have quite a few numbers here that we've returned. So hopefully this gives you a little bit of a comparison between the relational databases that we've been studying all semester and A NoSQL database, this is one of the document-based NoSQL databases that are available.